right, so the first thing I want to point out is there's a new variable that you've never seen before, and that variable is called slant height. Okay, so the slant height is the height of the triangle. So if the triangle was, you open it up, you take it apart, you're just looking, I wish I had my nets. The slant height is, oh, I don't have it. Where'd my pyramid go? Where's my big pyramid? Oh, it's over there. Oh, the big one. So then we look at the net, and we have 4 triangles here on this guy. And so I'm trying to find the area of this triangle. I'm going to need to know the height of the triangle, which is really slant height. Find that area. Okay? Moving on. So we put 3 of those into one of those. So we can say that the volume of a pyramid, the volume of one pyramid, is equal to something. We're going to write something. I'm going to leave that blank for now. Of the volume of the prism. So what's that relationship? Is the volume of one pyramid 3 times the prism? Or is it 1/3? Which one is a smaller volume? Okay, the pyramid or the prism? Who had smaller volume? The pyramid, right? It took 3 of these, 3 pyramids equal 1 cube. So we could also say that one of these filled up how much of the prism? 1/3. It filled up 1/3. It was 1/3 the volume of the prism. Okay, because it took 3 of them. So 1 filled up the prism 1/3 of the amount. So that's going to lead to our formula. So if we move over to the next page, we also looked at the cone. Okay, so the cone, again, also has a slant height and a vertical height. So the slant height would be, well, the slant height. It's slanted from the apex to any point on the circumference of the circle is your slant height. The vertical height is from the center of the circle, the base, the very center, all the way up to the apex, the top. That's your vertical height. So if that's the case, I'm just going to highlight this a little bit. Here's my slant height. Actually, right here. Here's my slant height, S. Here's my vertical height, H. And here's my radius. So what relationship can we make with that? Is there any relationship between those 3 variables? H squared plus R squared equals S squared. So we're only given one of those, or 2 of those, the radius, say, and the height, and we need the slant height. We have to use Pythagoras to figure out the missing side. We're given 2 of those and not the 3rd. So again, took the cone, right? It poured it in 3 times and equaled 1 cylinder. So the volume of the cone was equal to, how much did it fill up? 1 cone. How many, when we poured in 1 cone, how much of the cylinder filled up? Can we do it again? So here's my cylinder. Take my cone, pour it in. How much was filled up? 1/3. So the volume of the cone is 1/3 the volume of the cylinder. And that's why it took 3 cones to equal 1 cylinder. So this is going to give us our 2 formulas. Why? We already know the formula for a cylinder, don't we? What's the formula for a cylinder? pi r squared h. So the volume of our cone, if you look at the bottom down here, the volume of the cone, that's dark, let's use yellow. The volume of a cone, it was 1/3 the volume of a cylinder, or 1/3 pi r squared h. It's still kind of dark. Sorry. I won't highlight. I'll circle or something. Okay. So 1/3 pi r squared h, because this is the formula of our cylinder, pi r squared h. We're going to multiply by a third. For any prism was area of the base times the height, right? So it's going to be 1/3 that amount. So if our prism was just a simple rectangular prism, length times width times height, it would be 1/3. So if I have a pyramid that has the same dimensions, here's my prism, sort of. Nope, not very good. Had better days. What is going on here? Let's try this again. Close enough, okay? So if we had a pyramid in here, same dimensions. Okay, here's my rectangular pyramid. The volume would be, well, this is length, width, and height. It would be 1/3 length times width times height would be the volume of that pyramid. 1/3 of the prism. Okay. All right, so let's get to some actual examples. The Great Pyramid of, I'm going to say this wrong, Giza? Yeah, Giza. It's considered to be one of the 7 wonders of the ancient world. It was approximately, have you seen it before? No? Okay, well, I should show you a picture. Or you can Google it. Right? Pyramids of Giza, they're really pretty. Yeah. It's in Egypt, isn't it? Does it even say that? There it is. Here's Wikipedia. See if it shows up. There it is. This guy. Isn't that nice? Don't you want to go there? Really? I know, it's like, it's pretty impressive though. Okay, so that's that. So, there it is. Now you have a picture in your head. It's approximately 147 meters tall and has a square base, measuring 440 meters. Okay, so when you're drawing the square base, draw it like a parallelogram. When you're trying to draw, I'm not the greatest at pyramids, but, and then I just pick a point, kind of like, here's the center of it, so straight up above there, and connect all the sides to that. Something like that. Yeah, this isn't very good. Sorry. A lot of you are better artists than I am when it comes to pyramids. It's not easy, okay? Okay, and they give us the height, approximately. So that's the middle height here. I'm going to zoom in, because this is hard to draw small. 147. Can you even see that? No. Let's make it even larger. That's better. Sort of. Do you see the 147? Right there. That's the height. Okay. Right angle. Okay, make a sketch of the pyramid and let's calculate what? The volume. So the volume of any pyramid is 1/3 the volume of a prism. So what's the volume of, if it was a prism? How would I figure that? Any prism, what's the formula? Area of the base times height. Okay, area of the base times height. What is the area of the base? How would I get the area of the base here? Length times width. So it would be What times what? 440 times 440, or you could also use 440 to the power of 2, and then multiplied by the height. I'm going to use a dot there instead. What's the height? Do we need, no, so when we want volume, we always want the vertical height. So for surface area, we need slant height. For volume, we want vertical height. So that is 147. Okay. Does everyone have their formula sheets on them? Okay. So let's just type this in first, and then we'll grab our formula sheets and look at them. So 1/3, 1/3. You can also do your answer divide by 3 instead of 1/3. Times 440 times 440, length times width times height. It's big. 9,486,400 meters cubed. Okay, I'm just gonna open up, grab your. So here it is, length times width. So that's for a square pyramid. Technically, notice it's the same formula that we wrote down for a rectangular pyramid. The only difference here is the length and the width will be the same dimensions. So you could have also had side squared times h. 1/3 side squared, right? Because this has an s in it. Is this an s? What letter is this on your formula sheet? I don't know why they use s. It's because it's a square. Side s. It's very confusing in terms of the slant height. Usually slant heights are s's. So that's why it's kind of confusing. So when they're saying length times width, s times s, you could also write as s squared times h. But it's just less confusing that way, because you don't want to have too many s's meaning different things. So notice it's just length width times height. Length times width times the vertical. Okay? It's very important that you know that on these formulas, when they say letter h, they're always talking about vertical height. They're never talking about slant height. Okay? So you'll notice, is there a little s somewhere on any of these formulas? Where do you see a little s other than q? Other than q, sorry. On all of these shapes. Which shape? Yeah, the letter s in the formula. Yep. The right cone. So you see slant height right there? That's slant height. This h here is talking about vertical height. Okay. You're also using slant height in your surface areas, but the surface area formula you just have to break down the net. Right? So if it's square, we have 4 equal triangles and a cube on the bottom. Sorry, cube. Square. And then we'll talk about the rectangular one later. Okay. Oh, wrong one. Let's continue. Make a sketch of the net. So when we open this up, what does it look like? We open it up. Cut down the edges. See a square on the bottom with dimensions of 440, right? And then we have the sides. What shape are the sides? Triangles. Are the triangles going to be all the same? Yes, because it's a square base. So because it's a square base, you're going to have 4 equal triangles. If it was a rectangular base, the opposite triangles would be equal. So you'd have 2 sets of equal triangles. Okay? This right here, the height of the triangle, when you open up that net, remember I drew on that triangle, where is that shape? I lose things. Okay, when I open this up, this is called what? The height of the triangle is called? Is that the vertical height or slant height? That's slant height. Okay, we use slant height for surface area. S, that's S, the slant height. So we need to figure that out. So if we look at this shape up here, this is the same that we already drew, this amazing drawing up above. That's the slant height, right here. Okay, that's our slant height. So we need to make a right triangle and solve for our slant height. This is my slant height S. The vertical height was 147. Okay. The question is, what is this length right here? I highlighted green. 220, half of the square dimension, the side length here. Okay, so the distance from the very center to the edge is going to be half one of these. So 220. Oh, that is not a pen. 220. So we need to find the slant height before we can find, why am I drawing this out? So that I can find the area of one of these triangles. I need that slant height so I can find the area of the triangle. So how do I get that then? S is equal to square root of what am I using? What theory? Pythagorean. Yeah, theorem. Not theory, theorem. Pythagorean. Square root of 147 squared plus 220 squared. So approximately 264.59. Is our slant height. Okay. Now that we know our slant height, what can I find? So you can find the area of the triangle. What's the question asking me to find? It says make a sketch of the pyramid, calculate the surface area to the nearest square meter, explain why the base is not included in this calculation. Why is the base not going to be included? Why are we not going to include this base in surface area? Think about the problem. What pyramid is this? It's that one, right? So when we're talking about surface area, what are we talking about? It's not, yeah, because it's an exposed area. No, you want the exposed area. So you can't lift that up. It's not, we don't want that. So we're just including the 4 triangles. That's all we want to find is the 4 triangles. So our surface area is going to be equal to 4 times the area of one triangle. Area of a triangle. What's the formula for the area of a triangle? Base times height divided by 2 or 1/2 base times height. Both are the same. You can write it either way. Doesn't matter. Okay, so 4 times 1/2 times, what's the base of our triangle? What would be that base length of the triangle? 440. What would be the height of the triangle? No, height of the triangle, not the pyramid. That's where we found this. That's where this is going in, okay? The slant height is the height of the triangle, okay? When we're talking about the height of the triangle, that's slant height. 264.59 approximately. So you probably want to use the exact value in your calculations. 4 times 1 divided by 2 or 0.5 times 440. And then I'm going to go times the answer. How do I get answer? Second negative. Okay. So make sure you get the same number. 232,000 to the nearest whole number. 800 and no, 800 and the nearest whole number? Oh, okay, so this is where even, you probably just typed in 0.59, didn't you? So I've typed an answer. So I got all those decimal places. Notice how that changes the number. So even though I wrote this, I'm actually using that exact value. I used answer. So it's going to be more accurate. 0. Yeah. So when you have such big pyramids like this, that's when it makes a big difference. A small pyramid wouldn't make a big difference. It wouldn't make a difference. Is it meters? Yeah, meters cubed. Oh, no. Surface area. What is that? Meters squared. Meters squared. Okay, we're going to do 2 more questions. So by 2 more questions, I mean we're going to work on number 2. Okay, so number 2, let's look at number 2 here. And then I'm going to add 1 more question that's not in your workbook. Okay. A cone-shaped container has a height of 15 centimeters. So we have a cone. Cones are way easier to draw. Little. But they have no ice cream. It's true. Nowadays cones, unless you had a waffle cone, they're not really shaped that way. Okay, so it says the height is 15 centimeters. So where does that height go? Is that going to go vertical height, or is it going to go along the side, the slant height? That's vertical. They just say height, they're talking about vertical height. So that's the 15. And a base diameter of 16. Do we ever want diameter? No. What do we actually want? Always the radius. So if the diameter is 16, what's the radius? 8. Half of that. Okay. Determine the volume and surface area. So if you look in your formula sheets, so we have a formula for volume for a cone. See it at the bottom? Way down here. 1/3 pi r squared times height. So volume is 1/3 pi r squared h. And that's because it's 1/3 the cylinder volume. Do we have everything we know to find volume? Do I know the radius? Do I know the height? Yes, if it's h in the formula, they're talking about vertical height. We know that. So we can go ahead and type it in, find the volume. That's easy. Find the volume. So 1 decimal place, I think it says, right? So 1 decimal place should have 1005.3. Did we square the 8s? Remember the 1/3? Pi. Oh, there we go. 0.3, I think, right? Centimeters cubed. Okay, what's the formula on your formula sheet for the volume? Or no, volume, surface area. So pi r squared. Where does the pi r squared come from? No. What formula? What shape is pi r squared in the area of pi r squared? Yes. A circle. So that's the circle base. The pi r squared. The pi r s is the formula, which we're not going to prove, for if you cut open the cone, like that shape that looks like, so if you drew a net of a cone, it would look like this, and then you have something like, this. Okay, it has like a curve on the bottom. We're not proving how to get that area, but it's So the circle part is the pi r squared. The pi r s, so if you actually have your formula sheet, you actually might want to write on it. When you're finding that this is the circle, right? This is the pi r squared. The bottom part is pi r squared, and the side is the pi r s. Or right here, circle, and this is the side. So that you know, if I don't need the circle base, I'm only going to use pi r s. Because there are cases where you have a cone, and if it's setting it down on the ground, and you don't need the bottom. Or maybe you have an ice cream cone, literally, that you're finding the volume of. So you have a hemisphere on top of a cone. You wouldn't need the circle part, because we want the exposed area. Okay? So you need to know what everything stands for in your formulas. Okay. So back to the question. Do we know everything we need to know? No, what don't we know? The slant height. We do not know S, the slant height. Okay, so we're going to use Pythagorean's our first step. S squared equals 15 squared plus 8 squared. So that right triangle that's inside the cylinder. Or, sorry, cone, not a cylinder. Square root that. $289. So what's the square root of 289? I think it's a nice one, like 13. No, not. What is it? Is it 13? Oh, 17. It is nice, but it was off. Yeah, I guess it would not be 30. That makes sense. Okay, 17 centimeters. So now you can just sub it into your formula. Pi times our radius is 8 squared plus pi times my radius of 8 times my slant height of 17. So I'm just subbing it into this formula, right? Where r is 8 and s is 17. So the one decimal place should get 628.3. Okay. You can cancel out example 3 and 4, and we're going to draw in our own example. So you might want to write it in. I don't think there's any nice pages. You might have to go to the back of your book. You can do number 16 in your homework? Yes. Okay, very back of your book, either in your, if you have a notebook you want to write in, or if you turn to page like 663, there's notes page 1. Find somewhere to write this last example. Okay. And that's a rectangular pyramid. Hey, here's one. We're doing one example. Anywhere. So there's a note section at the very back of your workbook. You can write it in there. There's blank pages, or in lined paper that you have. Doesn't matter. Okay? Yeah. Find surface area and volume of a right rectangular pyramid with length 6 centimeters, width 8 centimeters, and height 4 centimeters. That doesn't make sense. Sorry. I should have said length is 8 and width is 6. Right? Yeah. Sorry. Same thing, but not. Not proper. Length 8, width 6, height 4. Because length is always the long side. So you're going to try and draw yourself a rectangular pyramid. Hopefully you can do better than I can. Oh, that's so bad. Eek. Let's try that again. Wonder if I could cheat. Probably not. There's no volume. I try this. It's not, it's hard, okay? Pyramids are tough. They're so tough. Okay, so length is 8, width is 6, and height is 4. I don't know what that is. All right, so go ahead and find the volume of this shape. What's the surface area, sorry, what's the formula for volume of a rectangular pyramid on your formula sheet? One-third length times width times height. Volume is easy. Go ahead and find the volume. It's surface area that's going to be awesome. Oh man, we are running. What time does class end? We have 4 minutes because I have to hand back your tests. Right? Darn it. Okay, we're gonna book it together. Length is 8 times width is 6 times 4. What did we get? 64 centimeters cubed. Okay, so when we draw this net, let's open this up. You have a rectangle at the base, which with dimensions 8 and 6. Okay, and then we have 4 triangles. Now, will these 4 triangles be the same dimensions? No. 2 of them will. The 2 opposite ones will. So you have 2 separate sets of triangles, meaning we actually have 2 separate sets of you don't know? Slant heights. Okay? They don't have the same slant height. This we can call S1. So this here is S1. On the side there. There's also the slant height for this guy. I'll call him S2. The one in front. S2. Okay? This slant height here. S2. So we have 2 different right triangles that we need to figure out slant heights for. All right? So I'm going through this pretty quick. So if we look at S1, if I kind of draw, here's S1. What was the vertical height? 4, right? For S1, what's this length down there going to be that I highlighted in green? Not 3. Look at the dimension that's in front of it. That's parallel to it. This right here. So what's parallel to that? 8. So if 8 is this full dimension, how much is that one right there? That's going to be 4. Okay, so this is actually 4 right here. So S1 is equal to the square root of 4 squared plus 4 squared. This is the most complicated it can get in this unit. For real. Okay? Finding the surface area of a rectangular pyramid where you have two separate slant heights. The biggest mistake I have is in the Pythagorean theorem. Students will either make this dimension right here, they'll make it, because they look at this x1, they're going to use the 6. Yes, that's the base of the triangle, but this right triangle inside is half of that length. That's the biggest mistake. So square root of 16 plus 16 is root 32, or I don't know what. Let's figure that out. Is 5.66 approximately. Okay, centimeters. So now you could find the area of that side triangle because we know S1, right? So let's do that. So side triangles, there's two of them. So the surface area is going to be 2 times, what's the area of a triangle? 1/2 times base times the height of the triangle, which is really, in this case, the slant height. Can you make that formula any simpler if you wanted to? What's 2 times 1/2? Just 1. With me or no? So you could actually make that formula for the 2 triangles, base times height, because these 2's cancel out. Okay, so that side triangle, what was the base length? The side ones. We're talking about, when I'm talking about side ones, I'm talking about these triangles right here. Okay, those sides. So what's the base of that? 6. What's the slant height, or the height of that triangle? 5.65, yeah, approximately 5.66. Okay, so we're going to take our answer, our previous answer that we had already in our calculator, and multiply it by 6. So the 2 side triangle surface area is 33.94. Okay. Okay, let's do the front and back triangles now. So in order to do that, I need to find the slant height number 2. So if we look at the triangle that's here, what's that dimension I just drew in? I'm going to highlight it. So we're looking at this right triangle right here. That's the right triangle that I highlighted. Okay, so that triangle, just kind of like sticking out like this, it is a right triangle. Height was 4. This is S2. What's this base dimension going to be this time? What's this length right here? It's going to be 3, half of the 6. It's parallel to 6, so it's half of the 6. This is a 3. Okay, so we're talking about the yellow triangle up above. It's because it's on a side, so it doesn't look like a right triangle, but it is a right triangle. Okay, because it's parallel to the 6, it's half. That base here is 3, right here is a 3. Okay. All right, so this works out to be the slant height. It's a 3, 4, 5 triangle. So when you actually go square root of 4 squared plus 3 squared, it equals 5. 3, 4, 5 triangle. Because you get 16 plus 9, which is 25. Square root of 25 is 5. Okay. So now we know this dimension, this S2 here is 5. Okay. So surface area of the 2 triangles, front and back, there's 2 of them. What's the formula for a triangle? Base times height divided by 2, or 1/2 base times height. What happens with the 2's? Cancel. Base times height. And we're talking about slant height, right? You can change this to be base times S2 if you wanted to. Because really, the height of the triangle is, of the front and back triangle, is that slant height. So the base was how much of that front back triangle? 8 times, what was the slant height? 5. We found out over here. S2 is 5. 8 times 5 is 40. Okay, so we finished finding the triangles. That's the toughest part. We have 2 different slant heights that you have to find, 2 different right triangles. The last part is, what else do we need to include? So we got the front 2 triangles, front, back, the side 2. What else? What other shape is here? The rectangle, 1 rectangle. Yeah, so we also have this rectangle in the middle here. Okay, so the rectangle, formula for a rectangle? Length times width. So that would be 8 times 6. And what's 8 times 6? 48. And so your total surface area when you add these all together is 40 plus 48 plus, we're doing it anyways. We're going to pack up in 2 seconds. What does that all add to? Somebody give me the answer. 121.94 centimeters squared. Your formula in your formula sheet, very similar. It just says the area of the 2 triangles on the side, the area of the 2 triangles in the front and back, and the base. You have to break it down, okay? Toughest part of this unit. The homework's on the board, so you can circle that. I'm actually going to get you to pack up everything, put it all away right now, okay? Because I'm handing back your test right now. Everything away, nothing on your desk. Cell phones need to be put away.